The Nasuni platform has always provided robust data protection capabilities. Our continuous file versioning technology allows customers to rapidly recover from a ransomware attack. While the ability to rapidly recover from an attack is critical, we heard from our customers that we need to help them identify when a ransomware attack occurs and take steps to stop it. So we developed our ransomware protection add-on to detect attacks and shut them down before they can cause excessive damage. With our latest release, we are combining our rapid recovery capabilities with our ransomware detection and mitigation capabilities to streamline the post-attack recovery process. Administrators will be able to recover the files that were impacted by the attack without having to pick and choose individual files or folders. The system will do that for them. Here I have a volume with ransomware detection and mitigation enabled. Over on my client machine, we can see some example data that we will use during a simulated ransomware attack. The simulator will go through all of the files and attempt to encrypt them. Ransomware protection is monitoring the file system activity created by the simulator. As it recognizes a ransomware pattern, and as the simulator reaches the established thresholds, the edge appliance will notify the administrator of an attack and take steps to contain it. As you can see, the mitigation policy has been triggered and the attack has stalled out. Back in Windows Explorer, we can see a progress bar being slowly drawn across the window, indicating that my client no longer has access to this edge appliance, and we can see that there are several files with the deadbolt extension. Back in the NMC, we can see that an incident related to the simulation has been created. From here I can view a report summarizing the incident, including the scope of the attack and the actions that Nasuni has taken in response. What we've added in this release is the ability to launch a targeted restore process. Next to the report button is a new targeted restore button. Clicking this opens a dialog via which I can set up a restore job. The NMC has already populated key pieces of information for me, including the snapshot that will be used for the restore. There are generally two processes ransomware follows when encrypting files. It can either encrypt in place and rename the file after the encryption is complete, or it will create a new file with the encrypted contents of the original file and delete the original file. In the rename case, we know the original file name because it is tracked as part of the rename operation, so it is a straightforward process to do the restore. In the delete case, we don't know what the original file name was because the operations were spread out over several events. Since it can be difficult to determine which process a given ransomware variant uses, you should always define the ransomware pattern when conducting a restore. We start by looking at the violation sample field, which provides an example of an encrypted file. In this case, the pattern used by the ransomware is the deadbolt file extension, so I will add that to the ransomware pattern field. As I type, notice that the original file name field updates to show the expected original file name. This is the file name that the system will look for in the snapshot. In the advanced settings section, I have several options that I can use to customize the restore job. The first is the option to have the system delete the encrypted files for me. This saves me from having to go through the file system myself and clean up the encrypted versions of the files. I also have an option to back up existing files that may have already been replaced by someone else. Finally, I can choose to restore the files to a different location. Once I am satisfied with my configuration, I click the Restore Files button, confirm that I want to perform the restore, and the NMC takes care of the rest. We can see a status message associated with the incident while the job runs. In a matter of moments, the restore is complete, and when I go back to Windows Explorer, we can see that the previously encrypted files have been restored. Now when I open the incident report, we can see a new entry in the timeline and timeline details, reflecting that a targeted restore has been performed. A full log of the restore operation is available via the .nasuni directory at the root of the volume. An administrator can use this log to see all of the files that were restored and to troubleshoot any problems with the restore process. Combining Nasuni's rapid ransomware recovery capabilities with our ransomware protection add-on allows us to further reduce the mean time to recovery from a ransomware event. This ensures that users are returned to productivity quickly and that our customers do not have to be concerned with paying a ransom.